The notation that is now known as the Siteswaps, the numbers, 663, whatever, I found out about when I went to the San Jose convention and I met Paul Klimek for the first time. And he was doing what I thought was my tricks that I had sort of invented on my own. And I go there and I see him juggling, and I went over and introduced myself to him, and he was using that notation, which I immediately understood and agreed was superior to my own. And I don't know of anyone prior to that who had been using that notation. I do know that there was a letter written to Juggler's World under the name of Charlie Simpson, which I found out later was Charlie Dancy, who described these n beat throws. There's a 5-beat throw and a 2-beat throw, and what he had called a 5-beat throw we would now call a 6, if I remember correctly. So he was subtracting 1 unit of the throw sequence. I think that the clearest impression is if you're juggling 6, those throws are 6s, and that really is the superior one. I'm not aware of the use of that kind of notation prior to Paul Klimek, who I first met in 1986. And so with respect to the history, I think that's sort of when it started. I don't know when Paul claims to have thought of it. It must have been well before 1986, because he was accomplished in 1986. And whereas I had just thought of them, I would say sort of in November, December 85 or January 86. I can't be totally sure that what I'm about to tell you is exactly how it happened, because these are thoughts from 20 years ago that I'm attempting to reconstruct, and at one time or another all of these thoughts did take place, and I think that this is pretty much the gist of it. And that is, it goes through a segue about real juggling. And I could say that my standards for real juggling are a lot lower than Sergei Ignatiev's. He has been quoted in Juggler's World as saying, juggling, that is to say real juggling, begins at 9 rings. I have a lot lower standards. For me, real juggling starts at 5. And I have a specific reason why I think that this is true. And that is, if you are juggling 3, and also if you're juggling 4, and you throw one too high, you can just wait. If it goes up too high, you just hold the other 2 if you're juggling 3, or if you're juggling 4 as 2 in each hand. The one that went too high, you can just hold the other one and wait for it, and whenever it comes down, and then you go back into the pattern, and that's okay. But with 5 balls, you have 1 in each hand, and 1 pending on each hand, and 1 extra. So if one of them goes too high, you can't just wait, because there's something else which is already, impending on whichever hand it is that you would have otherwise waited with. So you can't just wait. And another way of saying that, there's a couple of other ways of saying that. 5 is sort of the first level where it really has to be done correctly for it to be done at all. And another way of saying it is that 5 has this sort of magical appearance that there's just too many. You can sort of see how on a 3-ball cascade, there's one up there and it's coming for this one, and you switch it. And with 5, no matter how you count them, no matter how you do the accounting, there's an extra one in there somewhere. And so I sort of got this idea that 5 is this magical number where it's really juggling because it has to be correct for it to work at all. And by the way, it has the corollary, which you cannot change the throw heights arbitrarily. It has to be clean in order for it to work at all. And then I realized, but wait. It could be that if you throw one too high, it would then land exactly when another one is supposed to land, but then you throw that one that it would have collided with, you throw it lower so it lands in the earlier position. And so actually it would be possible to have a 5-ball cascade where they're not all going to the same height. And this is exactly what then caused me to coin this concept. These are Siteswaps. They were supposed to be that this ball would land here and another ball would land later. But if you throw one too high and then the other low enough to sort of take its place, skip ahead in time, you would have swapped the balls within these fictitious sites that are unchangingly staying in the correct pattern. And then I realized that what one could imagine was a bunch of juggling tricks where the juggler looks like he's totally out of control. The balls are going to all these different heights, and there's no apparent pattern, and in fact it could be random, so there could be no pattern, because you're just doing tricks, butted back to back with one another with no, period or any repeat sequence, depending on the level of your ability and your memory to remember the tricks. But it would be this complete disaster, but the balls are nevertheless falling exactly in time, exactly alternatingly. Every time the juggler puts his hand out, somehow a ball manages to fall into it and then goes into some unpredictable new future height. And that you could do that, and that would be perhaps interesting or even baffling to jugglers who, quote unquote, who know that you can't throw to arbitrary heights in 5 balls and have it work, because for the reason that I just gave. And so I realized that there was a universe of tricks out there, which, by the way, I had never seen. By this time, I had seen, circus performers, and I had gone to the LA Valley College, later called the Safety in Numbers Juggling Club, which is something that I coined, incidentally. And there's all these professional jugglers. The Raspini brothers were there. Dan Bennett was there. Bob Mendelsohn. There's some people who have who are known in the juggling community, and nobody was ever doing tricks like this. So I thought I had something. That was sort of the origin of the thought. And upon thinking about it more, I realized that it was connected to the idea of permutations. If you throw the balls up in a certain order, if you throw them all to the same height, of course, they're going to land in the same order that they were thrown in, just delayed in time by however high you threw them. But if you throw one of them too high and then another one lower, that basically reverses their order. And so not only does that again sort of compel the name Siteswaps, but it also makes a connection between permutations and juggling tricks. So any permutation that you could write down, a sequence of A, B, C, D, E turns into C, B, A, D, E, okay, that is uniquely a juggling trick. And so there's a one-for-one connection between permutations and possible juggling tricks. It was not only a notation that was descriptive, it was actually a creative thing. You could create a new trick which did something that you wanted it to do. If you wanted to have a very high throw or something, you could delay it considerably and then have to work out where the other ones go so it doesn't land in that place that you now, you occupied with this high throw. And to think about that, what I did was I created, as so many other people did, these ladder diagrams, which show dots alternating downwards, and the dots are the moment that the left hand throws, and then the right, and then the left again, and then the right. And then from one dot a ball is thrown and it lands at some future dot, which is down lower, and then there's as many connections between these dots as there are objects in the pattern. So, for example, if you slice one of these patterns across horizontally, you cut as many threads as there are balls in the pattern. There's 3 or 5 or whatever it is how many you cut when you snip the pattern in half. But any one of the objects you can follow along as it goes from the right hand to the left to the right. But if you decide, for example, a trick that I thought of was, how would you eat the apple in 5 balls? And at that time, I didn't think that it was possible to steal a bite during a 5 cascade without any artificial trick. I now realize that you can. You can be really quick if you want to. But what I thought would be necessary is, for one ball, you hold for 1 unit's worth of time, which would now be called a 2. And you then shuffle whatever the other ones have to do. You can draw on the paper, okay, this one gets a hold. It just goes to the next site without being thrown, and then all the other ones kind of have to make way around it. And I came up with 7-5-6-2 as a nice trick for purchasing a 2, but it's nice in another way, at least for me, as a very right-handed juggler. The right hand does a 7, which is a hard high throw, and then the left hand does a 5, which is to say it's the same as it is always doing. It's no different, so it's not any hard thing for the left hand to accomplish. And then the right hand does a 6, And then the left hand now has a 2 purchased on its time, so it could then, you could take the bite out of the apple if you managed to get the apple to be the place where the 2 was.
The diagram.
Yes,
yeah.
and so for me, the juggling trick was this it looked like a sort of a braid of wiggly lines going down a sequence of dots, and that was the trick. And what I thought of it as was the throw heights, and of course it's totally obvious on the ladder diagram. It's fundamental whether a ball crosses or stays on the same side, and which is now understood as it was an odd number throw or an even number throw, which I didn't think of immediately at the time. That wasn't a connection that I had made at that time. And probably if I had had another 6 months or a year or something to think about it, I probably would have come up with a number scheme and the odds and evens and all that stuff. But I met Paul Klimek in San Jose while it was still sort of a half-baked scheme, and then he had already thought of all of those things, and I immediately understood it, and oh, of course, and that was really was the correct way to think about it. It's much simpler to think in those terms than as these woven diagrams on dots. I was.
Yeah.
I had no collaboration. I was sort of at that time in my college career more interested in juggling in some cases than in my schoolwork. I was not a particularly spectacularly successful part of my college career, and I sort of was distracted by juggling for other reasons, and I was sort of pursuing it with a sort of a single-minded devotion, as it were. I was very much off on my own at that time. Although that said, after the San Jose convention, and learning about the numerical method, the numerical notation of denoting the tricks, I then wanted tables of all the tricks, and I solicited the help of a computer programmer to generate permutations and then translate them into tricks. And the first person who accepted the task of writing them down was a man by the name of Joel Hampkins, a classmate at Caltech at the time. And I can't remember, unfortunately, the name of the computer program that he used. It was not a common one. It wasn't BASIC or Fortran or C or something. It was like Algol or some other more esoteric program. But it had permute, a list of elements, as one of its hard-coded functions. And so it was very natural to generate for a sequence of a given number of throws all of the permutations and then translate those into the tricks. Unfortunately, it generates them in the order of permutation, and so there was an impossibly slow process of sorting, doing a bubble sort to sort all the tricks into order, as it were. And so it was impossibly slow to generate what we would now know of, a table of tricks that have this many balls and this throw height and so forth. It was incredibly tedious to do that. And I have to acknowledge Jack Boyce's seminal contribution of the state space algorithm, which made computation of tricks unbelievably quicker and superior. You could exclude certain throw heights, and you could do all this stuff just naturally within that paradigm, which you could not do in the permutation paradigm. So I would be remiss not to mention Jack's fundamental contribution. Bengt also had a contribution in that he was just starting to juggle, but he was very computer-oriented or connected. I was a chemist at that time, and I didn't know about the internet, the World Wide Web. Actually, I don't think it even existed yet. But there were list servers, electronic bulletin boards, which I didn't know about. But one of them was Juggling, which I didn't know much about. But Bengt was a member of that, and he engaged the members there by describing Siteswaps and also posting lists of tricks. Acknowledging that they were slow and difficult to calculate. Wouldn't it sure save people time if he published lists of them, so that other people didn't have to tediously calculate them? And That rubbed some people very, very much the wrong way because, first of all, they didn't understand siteswaps, they didn't understand what these numbers were, and they were offended, even horribly so in a couple of cases, that what had been a pure, beautiful art form of juggling had been reduced to these heartless, soulless numbers, and that all of the life had been drained out of them. And anyway, they were meaningless numbers because they didn't know what they meant. So Bengt managed to incur some hate mail for contaminating this juggling discussion with these mindless, senseless lists of numbers. Although later it turns out we had at least a couple of converts who, after they figured out what siteswaps were and the fact that these numbers meant throw heights, and you could, each one of those numbers was a sequence, was a trick, that he then, at least one in particular that I'm thinking of, came around and thanked, oh, now that I understand, this is brilliant, it's wonderful that you can do this, and thank you for posting them, and so on. I didn't realize what you were talking about. And he apologized and then later became very fond of the tricks. But there was a certain amount of hate mail before that moment happened. A few years later, actually I guess about a year and a half later after this, I worked out a bunch of consequences, physical consequences of juggling, starting basically from Shanon's little theorem, which this is the Shanon of information theory, and he has a big theorem which everybody knows him by, which is relates to the entropy of information, information theory concepts. But he has another theorem, Shannon's little theorem, which is about juggling, and what it is it relates a juggling pattern from two frame points, 2 points of view. One of them is that in a juggling pattern, if a ball goes through a round trip and then returns to its original place, that takes the same amount of time as a hand that goes through all the balls until it gets back to the same ball. And the two lengths of time, of course, have to be identical. And so on the one hand, you have the number of balls times the hand time, the occupancy time, plus the number of balls times the empty time, in between each ball, and that's the hand's eye view of the juggling pattern. And then the ball's eye view is you have one air time, and then one hand time, and then another air time, and then another hand time. And those two times have to be the same, because ultimately you're talking about the same juggling pattern from these two different viewpoints. And Shannon wrote that one down for the first time. And starting from there, it's pretty easy to work out how many throws per second you have to make with this many balls if you throw them this high in this kind of gravity, for example. And so one obvious thing that you could work out is, if you can juggle 5 balls on the Earth, how many can you do on the Moon, where gravity is 1/6 of what it is here on the Earth. And it's quite straightforward to start with that equation. You write down a different number for g, and you come up with how many you could juggle on the Moon. And incidentally, I do think that it was tragic that the astronauts brought a golf club and a golf ball and an eagle feather and a hammer to drop in the vacuum, when they really should have brought a bunch of juggling things. As long as they were taking the trouble to go to the Moon, they could have used, in my opinion, the opportunity much more wisely than bashing a golf ball out to the next crater. But anyway, they didn't, and if I ever find myself on the Moon, you can be sure you'll find me with a juggling bag out there. Anyway, you can work out how many you could do on the Moon, and as I remember, it's something, I don't remember exactly what the number is or what my starting assumptions were, but you end up with numbers sort of in the teens. 15, 17, 19 is moderately good to an expert terrestrial juggler. That's what it turns into up there. And one can wonder whether you could take care of the collision problems or you couldn't take care of the collision problems up there. But with respect to the physics, how fast are you throwing it up for that high and so forth, that's what it works out to be. I had also worked out a result that gave rise to the concept of a natural spin. If you hold a club and you throw it up, even if you don't flick your wrist, even if you just hold the club rigidly parallel to your arm, as you move your elbow up, it's rotating. I mean, it's pointing down at the ground, and then it's horizontal, and then it's pointing up. It means that the club is really spinning, even though you're not torquing it with your wrist. And if you just let go of it, it would continue to spin. And I worked out, just based on that simple physics argument, that if you then throw a single with that kind of throw style, it's just half as high as if you throw a double. It works out that, yes, it's true, if you throw it harder, it'll go higher, but it's also spinning faster, and it works out so that just twice as high is exactly a double spin compared to a single spin, and so forth. And I call these natural spins because they're not artificially assisted spins or whatever. It just has to do with the motion of your arm, your forearm around your elbow. And I worked out that, for example, in a 5-club cascade where you're using double spins, if you use a dwell ratio, which is to say that half the time your hand is occupied by a club and half the time it's empty, it's between having just made a throw and catching. If those two time periods are equal, then half the time your hand is holding a club, and that's a dwell ratio of 1/2. That by the time you have thrown one object and you're getting ready to throw the next one, it will have just done exactly half a spin. So all the clubs are lined up anti-parallel to each other, which is something I had noticed. It looks like they're all horizontal or they're all vertical in a 5-club cascade. Something that many people can see if they blink their eyes during a 5-club cascade. You can sort of stop it at a moment and see that they're all lined up. I worked that out on paper from relatively simple physics arguments, basically. And Bengt heard of that. He saw my calculations and so forth and thought it was interesting. And unlike me, he was actually a physics major. So he replicated all of my results and then went considerably beyond them, touching on things like viscosity and the Coriolis forces. You know, in the movie 2001, there's this guy who's running around a mouse wheel, you know, getting his artificial gravity because he's running around in this circle. And what would it be like to juggle in those? And he worked out some consequences of that, or juggling, passing on a merry-go-round where Coriolis forces would be very much not negligible. He encouraged me to write up a paper which we then submitted to the physics teacher, which was a journal basically for trying to bring some real-life interest into your subject matter. We were actually the cover photo of the November 1989 issue of the Physics Teacher. I was doing a 5-club cascade, by the way, which showed the clubs being anti-parallel. We took a bunch of pictures, and I will confess we selected one which showed it really well. But it's true, most of the time that effect is being demonstrated. And he was doing 7 balls, and we made comments about the 5-club pattern and how many can you do when you throw them that high and so forth. And so it was not just a photo of us juggling, it was actually somewhat topically related to the content that the paper was describing. And it was in that paper, the physics teacher article, that we also mentioned this class of tricks that we had discovered and or invented, and we named them Siteswaps in that paper, and that was, as far as I know, the first truly public disclosure of the trick's existence whatsoever. That paper was published in November 1989, and in comparison, I met Paul Klimek in July of 1986 at the San Jose Convention, and by which time 3 years, sort of 3 years or more later, and so there certainly wasn't any intention to steal someone's thunder or whatever. If Paul had had an intention, or anyone else had had an intention to publish, there would have been plenty of time to do it. But to my knowledge, nobody had, and the first public disclosure was this paper. There was another paper in 1991, which was the Siteswaps for the Masses, a notation for juggling tricks, a lot of juggling tricks, which which was submitted to Juggler's World. And that was mostly my efforts with a little bit of Bengt's contribution. It appeared in the summer 1991 issue, unfortunately shortly after he took his own life. I had called them Siteswaps well before San Jose. I realized that what is happening here is that the balls aren't, you're not waiting for the high one to come down. You're switching it with another one which advances in time explicitly, which is how you're able to throw one too high and another one low to make up for it. That's why it works, and the reason that it works is that you're switching the locations that they would have otherwise been. And so I thought of that name basically as soon as I thought of the scheme, that, well, what's happening here? Oh, they're all switching places. That they're getting shuffled, and that was key to the whole thing. So that was definitely something that I coined very early in the thinking process, and that name appears to have stuck. I am aware that that Paul Klimek called them quantum juggling, and he makes actually quite an impressive number of connections between the quantum world and the juggling world. And for example, he elucidated and he understood and named the difference between ground state and excited state tricks, which, by the way, shares an analogy to quantum mechanics. And there's a number of other analogies that one can make. And the juggling balls are in orbits and so forth. And I also know that, or I have heard that the Cambridge notation was what a group of people there were talking about or were describing their scheme by. But for some reason, Siteswaps seem to have
A favorite 2 or 3 Siteswaps?
Well, I would have to say that 771 is one of my favorite tricks, and I like it for a number of reasons. One is that since it's 3 throws long, it's not unfair to one's hand or the other. Both hands get it, equal effort. It shares some of the visual complexity of 7 balls, while simultaneously being a heck of a lot easier than 7 balls is. It's baffling to try to figure out what's going on in that trick. If you're not familiar with Siteswaps, I think by and large you can forget about it. It has a confusing, it's impossible to follow unless you know what's going on, basically. It's relatively easy to do as 5-ball tricks goes. It's straightforward. It has a nice rhythm, a sort of a galloped pattern, which is easy on the hands and comfortable to do. And I also think that I like it particularly because I think it's a good example of a trick which probably never would have been thought of without the whole scheme that thinks of all of them. And so, I mean, there are tricks like 4-2, where you juggle 2 in one hand and you have the third one that you can polish and eat, or whatever. You can think of tricks like that without the necessity of thinking of the whole scheme. But I don't think 771 would have accidentally been thought of just, as a happenstance. Oh, look what just occurred. And so it really compels the whole story. I just thoroughly like that trick. That's a good one. I also like 6671, which is another 5-object trick. I guess those are probably my two top favorite ones. That's an interesting philosophical question, and one could ask, were numbers created or discovered? And I guess I would have to come down on the side of that they were created. That the numbers aren't out there floating. It takes a mind to appreciate their existence, basically, and to control the piece of chalk that writes the number down on a chalkboard. and that mathematics is not a discovery, it's an invention, which, by the way, is great for bookkeeping. If you have to count things or whatever, it's great to be able to do that. And I think, philosophically speaking, the Siteswap scheme is basically the same as mathematics. It's something that was created. It wasn't out there waiting to be discovered. But every permutation has a trick, and you could certainly interpret. I mean, there are geometrical interpretations to mathematical equations. For example, the Pythagorean theorem, in a right triangle, the sum of the squares of the two sides is equal to the square of the hypotenuse. And you can make geometrical interpretations to that as well as proving it just mathematically. I will agree that there is a juggling interpretation to a lot of mathematical concepts. That is certain. So here are 5 originating throws, and in the 5 cascade, this one lands here, this one lands here, this one lands here, this one lands here, and this one would land here. And incidentally, if you were keep it going, of course, this proceeds over. And one comment that I made earlier, I don't think I'll need this, is if this is cut somewhere, you just slice it across, you get 1, 2, 3, 4, 5 objects are being tracked in this diagram. And what this is, of course, probably everybody knows this, but what this is the top view of a pattern where the juggler is sort of walking along, and then the balls light up, and you leave marks on film as the juggler walked underneath. So odd number throws cross and evens don't. But anyway, there's 5 of them there, and they're moving across from hand to hand in the cascade. And the origin, one of the first things that I wanted to be able to do, for example, or to suppose that you wanted to do this, was to say, well, we're going to keep one of these throws and not throw it at all. We'll do a hold. So for example, if you wanted to eat the apple, you could eat the apple right there. What would you have to do? And having constrained this, what you have to do is you have to get the other 4 throws to somehow get around this space. And it's probably easy enough to figure out what all has to happen. This is 2, but this one, it can't land here because that space is already taken, but it can land in the next one after it. And this one can do what it would normally do. And this one now, the next earliest spot for it is there. And now we have 5 more throws that are in the same pattern as they were. So you can now continue as before in the cascade, just like it was always doing. But you can now look at this and see what, starting from this line, what did the throws do? This one didn't get a 5. It got a 1, 2, 3, 4, 5, 6, 7. It landed here. So this was a 7. This is a 5. This is a 6, doesn't cross, and this is a 2. This, however, this label isn't, you don't have to label them to see the trick. Just the diagonal lines, or the weave already contains the information which is of the trick. And so by doing this, what I've shown is you can assert this throw is going to be a given type of throw. What do you have to do for the rest of the throws to make it work? And you can make them go however they have to go so that it works out again. And that creates a trick. And I think this is the first trick. The trick that we now call 7562 is the first one that I thought of as specifically, and I practiced and I could do it in the air.